Hello viewers. We know that OSI model has a layered architecture. It has 7 layers, namely physical layer, data link layer, network layer, transport layer, session layer, presentation layer and application layer as shown in the figure. Every layer is independent of the layer above and below in its implementation. Every layer accepts the services provided by the lower layer and provides the services to the upper layer. Today we will focus on network layer and discuss some very important and fundamental services provided by layer 3, that is network layer of OSI reference model. Network layer accepts the services provided by layer 2, that is data link layer, as input, processes it and provides the services to layer 4, that is transport layer. Each layer has its own specific set of services as shown in the figure. In this session, we will have a look on what processing is actually done by network layer and what services network layer provides to transport layer. Network layer provides two types of packet switching services. These are virtual circuit or connection oriented packet switching and datagram or connectionless packet switching. Network layer also provides 3 other related basic services. These are logical addressing, routing and path determination. In this program, we will take up types of packet switching and logical addressing, or commonly known as IP addressing. First of all, we will discuss packet switching mechanism at network layer. Viewers, as mentioned before, we have 2 types of packet switching mechanism at network layer. First is called virtual circuit or connection oriented service. Second is called datagram or connectionless service. Let us discuss these 2 mechanisms in detail. We will start with virtual circuit. Virtual circuit is connection oriented packet switching service. In this service, before starting any transmission between 2 computers on a network, a virtual connection is established. All the packets that belong to same communication session or message follow the same path. Packets related to one session contains source address, destination address and virtual circuit identifier. Now one thing that comes to the mind is that why the connection between sender and receiver is called virtual connection. This is virtual circuit because this service gives an illusion to the user that there is a dedicated point-to-point connection between sender and receiver, but actually there is no dedicated direct line between the sender and receiver. The connection is established as and when required and then released when not required. The information is carried in many small packets, each with a short virtual circuit number which identifies its virtual circuit over the physical link. As soon as the connection is released, the virtual circuit is also terminated. This type of communication is similar to a basic telephone communication. I will explain the similarity between connection oriented packet switching and telephone communication in a short while. Do remember that there are 3 phases for setting up a virtual circuit. These are setup phase or resource reservation phase, data transfer phase and tear down phase. In setup phase, virtual circuit is established between the hosts. To establish the virtual circuit, as first step, source requests for the connection and destination acknowledges the connection and connection is established. In second phase, data transfer takes place and after transmission of data, third phase comes in which virtual connection is released and virtual circuit is tear down. Packets through one virtual circuit maintain sequence and they are routed in sequence by using same route. Let us discuss the example of landline phone, which uses connection oriented switching. When a person calls to second person by dialing number, resource is reserved, that is phone line is reserved for that particular call. Phone at destination rings, this is basically a request for connection. When user at destination picks the phone up, the connection is established, that is virtual circuit is established. Picking up the phone means acknowledging the connection request. Now person talks with each other, that is the data transfer takes place. After completing the talk, the user disconnects the phone. Now disconnecting the phone means data transfer is over and connection is released. That is an established virtual circuit is tear down. Other example of virtual circuit is downloading a file using FTP, that is File Transfer Protocol. In this example, first user requests for the file from the server. If the server accepts the request, a circuit is established. File is converted into packets and sent to the requesting user through the established connection. All the packets that belong to same message or communication session follow the same path, that is the established virtual circuit. When the final download is complete, the connection is released and virtual circuit is tear down. Second type of packet service provided by network layer is datagram or connectionless service. In datagram packet switching service, no connection is established prior to the transmission. Every packet is routed independently. Every packet contains full source and destination address. There is no relation between the packets of same message. Packets belonging to same message can follow different routes to reach to destination, and no packet sequence is maintained. Packet switching in virtual circuit and datagram is done by a router or layer 3 switches. Our postal system is an example of connectionless service. Suppose two persons are communicating using traditional letters. The sender writes letter, marks this letter with the destination address and posts it in letterbox. The letter is routed to the destination through the route decided by the postal department. Again, the same sender writes second letter to the same destination using same process of first writing the letter, marking it with the address of destination and posting it in the letterbox. The second letter may follow different route as compared to first letter as decided by the postal department, which may be because of non-availability of earlier route or any other reason. Communication has taken place between sender and receiver, but contrary to the connection oriented service, in this case there is not any connection establishment phase before the data transfer. You must have understood that either we use connection oriented service or connectionless service, sender or receiver, commonly known as hosts, must be identified uniquely on the network. Similar to real life where each person has a unique identification, in computer networks each computer must have unique identification. For this purpose, we will discuss logical addressing or IP addressing, another very important service provided by network layer. Internet Protocol Address, or commonly known as IP address, uniquely identify the machine over the network. Two versions of IP address are in use, IPv4 and IPv6. Here we will discuss IPv4 only. Internet Protocol version 4 address is 32-bit long, divided into 4 octets, that is group of 8 bits separated by dot as shown. To make IP address more compact and readable, it is represented into decimal form. Each octet can have maximum decimal value of 255 and minimum decimal value of 0. This is because by using 8 bits, we can have maximum value of 255 and minimum value of 0. Same IP address shown in binary can be written as shown on the screen. Every IPv4 address has two parts. One is network ID or net ID that identifies the network to which that IP address belongs, and second is host ID that uniquely identifies the host on the network. Now, which of the 32 bits are to be used as network ID and which of the bits are to be used as host ID is dependent upon the requirement at hand. To make it simpler, IPv4 addresses are categorized into 5 classes. These classes are used to identify net ID and host ID of a particular host over a network, and this is done with the help of subnet mask. Subnet designates which part of IP address is to be used as network ID and which is to be used as host ID. If we require that first 3 octets are to be used as network ID and last one is to be used as host ID, then subnet mask will be in binary as shown, and the same subnet mask in decimal format is 255.255.255.0. Similarly, if first 2 octets are to be used as network ID and last 2 octets are to be used as host ID, then subnet mask in binary format and decimal format will be as shown on the screen. Another method nowadays used is CIDR, that is classless internet domain routing. In CIDR, net ID and host ID is identified from network prefix. Example of CIDR is 117.239.46.5/28. In this particular diagram, /28 signifies that subnet mask contains 28 ones followed by 8 zeros. Now we have learnt two techniques to represent subnet mask, one directly and other using classless inter-domain routing. Keeping in mind this concept, let us discuss different address classes. IPv4 has 5 address classes as class A, class B, class C, class D and class E. These classes differ in the number of bits allocated to the network ID and host ID. Every class is identified from its most significant octet or leftmost octet. Class A. In class A, IP address leftmost or most significant octet is used as network ID as shown in the screen. The range of first octet of class A is 0 to 126. Other 3 octets are used for host ID. The default subnet mask for class A is 255.0.0.0. So if IP address has decimal range of 0 to 126 for the first octet, it belongs to class A. For example, 1.1.1.1 or 120.10.10.1 etc. These are class A addresses. The range of IP addresses from 127.0.0.1 to 127.255.255.255 is reserved for self-testing and loopback. Class B. In class B, IP address 2 most significant octets are used as network ID. The range of first octet of class B IP address is from 128 to 191. Last 2 octets are used for host ID. Default subnet mask for class B is 255.255.0.0. So if IP address has decimal range of 128 to 191, it belongs to class B. For example, 128.10.12.132 or 190.34.38.140 etc. are class B IP addresses. Class C. The range of class C is 192 to 223. Left 3 octets are used for the net ID and other octet is used for host ID. The default subnet mask for class C is 255.255.255.0. So if IP address has decimal range of 192 to 223, that belong to class C. For example, 192.10.12.132 or 221.34.38.140. These are example of class C IP address. Class D and E are reserved for multicasting, research and development. The range of class D is 224 to 239 and range of class E is 240 to 255. There is no subnet mask specified for class D and E. Private addresses. Now every address class has a private range also. Private range is used for private network, mean private range cannot be used over internet. Private address range for class A, class B and class C addresses is shown on the screen. Now we move on to a new concept called subnetting, which can be used to create network of networks. Subnetting is a procedure to divide a network into subnetworks. It is very important for using IP addresses efficiently. Subnetting is the process of creating new networks or subnets by borrowing bits from the host portion of a subnet mask. There is one caution: borrowing bits from host creates more networks but fewer hosts per network. Consider the following class C network: 192.168.54.0. The default subnet mask for this network is 255.255.255.0 as shown on the screen. This single network can be segmented or subnetted into multiple networks. For example, assume a minimum number of 10 networks are required. Resolving this is possible using the following magical formula 2 raised to power n. The exponent n identifies the number of bits to borrow from the host portion of subnet mask. The default class C mask looks as shown on the screen in binary and decimal format. It is 255.255.255.0. There are a total of 24 bits set to 1 which are used as network ID. There are 8 bits set to 0 which are used to identify the host, and these host bits can be borrowed, which will increase the number of networks but will decrease the number of hosts per network, because borrowing bits essentially involves changing host bits in the subnet mask to network bits. Consider the result if 3 bits are borrowed. Using the above magical formula as shown on the screen, 2 raised to power 3 is equal to 8. So, 8 networks are created. However, a total of 8 new networks do not meet the original requirement of at least 10 networks. Consider the result if 4 bits are borrowed as shown on the screen. 2 raised to power n is equal to 2 raised to power 4 equal to 16. So, 16 new networks are created. A total of 16 new networks do meet the original requirement. Borrowing 4 bits results in the new subnet mask shown on the screen. Please notice the least significant 4 bits in the binary format of subnet mask. These will be used to represent the host ID. CIDR, classless inter-domain routing, is also called supernetting. Classless inter-domain routing is a simplified method of representing a subnet mask. CIDR identify number of binary bits set to 1 in a subnet mask preceded by a slash. For example, a subnet mask of 255.255.255.240 would be represented in binary format as shown on the screen. CIDR notation is /28 because leftmost 28 bits are ones in the subnet mask. So, today we have discussed various services provided by network layer. We studied about connection oriented and connection-less services, followed by IP addressing. Then we had discussion about various classes of IP addresses, subnetting and CIDR notation. I hope you must have learned the concepts clearly. Thank you.